All right, so now we'll be working on a challenge and a real-world connection for point-slope form. I encourage you to pause this video, give these problems a try on your own, and then check back in and follow along and see how you did. So for these challenge problems on the left, it's more practice with converting between forms. So we're going to try to convert these guys into point-slope form. And it looks like we have a slope-intercept form first, y equals 3x minus 5. Okay, I'm going to give you a couple options here, and I think you can choose either one you want. So I think the easiest way to do this, but it won't really demonstrate full point-slope form as much as it could. But the easiest way is to just realize we have a slope of 3, and we have a point of 0, negative 5. Okay, and we can just plug all that in. Y minus our y value equals 3 times x minus our x value. So y plus 5 equals 3x. Okay, and you might be thinking, that looks oddly similar to slope-intercept form. All we did is add 5 to both sides. And what happened here is this 0 just simplified quite a bit of our final form. Okay, so it's still point-slope form, but it doesn't quite demonstrate everything that point-slope form has to offer. So let me show you another possibility. Let's pick a random value of x. I don't care what we pick. I'm going to pick x is 9. Okay, so if x is 9, we're going to plug that 9 in for x right there, and we get y is 3 times 9 is 27, minus 5 is 22. Okay, so we can do another point-slope form where m is 3, and just plug everything in there. Y minus our y value equals 3 times x minus our x value. And then we're done. Okay, so two different point-slope form equations. Both are correct, okay, and both are valid for sure. Okay. Next one is a standard form equation, and we're going to work on trying to get that into point-slope form. And what I'm going to do here first is actually go through slope-intercept form. I'm going to get y equals mx plus b first, and then go into point-slope form. So let's solve for y. So we have negative 4y equals negative 3x plus 12, if we subtract 3x from both sides, and divide by negative 4, we get our slope-intercept form. And so now we know our slope is 3/4. So that's good to keep track of. And let's see, next we can again pick a random point. I'm not going to pick x equals 0. That's going to be simplify things a little too much. Won't really demonstrate what I want to demonstrate. But I want to pick an x value that's easily divisible by 4 that we could find 3/4 of pretty easy. So let's have x equals 8. And let's solve for y. So 3/4 of 8, and I'm right here right now, 3/4 of 8 is 6, and then take away 3 gives us 3. Whoops. So we have this point right here, point of 8 comma 3, and m is 3/4. So let's write it out. Y minus our y value equals 3/4 times x minus our x value. We got it. Now your final equation may differ. I chose to plug in 8, and if you plug in a different number for x, you'll get these numbers will differ. Okay, but if you do it correctly, they should still represent the same function. All right, and a quick real-world connection problem here. A tree grows at a linear rate. Its height in 2004 was 3.5 meters. Its height in 2015 was 5.6 meters. Using point-slope form, predict the height of the tree in 2020. So I want to deal with my years first, and I don't want to work with such huge year values. So let's have x equals years since 2000. Okay, so we have a couple points. We have year 4, it was 3.5 meters tall, and year 15 was 5.6 meters tall. All right, so let's find a slope first, and we are going to subtract our y's. 3.5 minus 5.6 divided by a subtraction of our x's. All right. So we have a negative 2.1 divided by negative 11, right? And so I get a slope of, I'll round to a couple decimal places, 0.19. So meaning this tree grows about 0.19 or about 1/5 of a meter per year. And does that kind of make sense? It grew, let's see, it grew maybe 2 meters in 10 years. Yeah, so that looks like that kind of makes sense. So let's write out our point slope form equation. We can say, and I'm going to choose this y value. I just always like choosing smaller numbers. So our point slope form equation, y minus our y value equals our slope times x minus our x value. And we want to plug in that year in for x, okay? Remembering that 2020 needs to be converted to just the year 20, since x is the years since 2000. So y minus 3.5 equals 0.19 times 20 minus 4. I can add 3.5 to both sides right away. That turns into a 16, the 20 minus 4. And then I'm just going to go to my calculator and run through that. So 0.19 times 16, and then adding on a 3.5 gives us y is 6.54. That's going to be in meters. Let's think, does that kind of make sense? So about another meter after the 2015 height. Yeah, it seems like it does make sense. So our tree will be about 6.5 meters tall, assuming it keeps growing at the same rate. That's a good place to stop right there.